backpack, allowing anyone to escape to the wilderness but stay plugged in. Production starts with a roll of thin plastic film. It's the same material used to make flat-screen TVs. A worker loads it into machines that distribute thin layers of aluminum and silicon onto it. The aluminum acts as an electrical contact. The silicon produces electricity when exposed to the sun's rays. Next, lasers carve vertical and horizontal lines into the film. These lines define the solar cells. An automated squeegee applies black ink through a screen and into the lines. The ink will act as an electrical insulator. It also makes it possible to cut through the film without damaging it. UV light cures the insulator ink. An employee pours a generous amount of metallic silver ink onto a pattern. A squeegee forces the ink through to the solar film. This creates a conductive grid on the film. A camera magnifies the grid for inspection. The solar film travels through a chamber where heat cures the silver ink. A laser now connects the solar cells, linking the bottom aluminum layer of one cell to the top silicon layer of the next. The laser ties them together, similar to how a soldering tool would. This establishes electrical connections and increases the voltage significantly. A different camera magnifies the connections to check the alignment. Now, a worker loads the solar film into a machine. It deposits a transparent oxide onto the film that will increase conductivity. These solar cells are now fully functional. The next machine tests each one. It also applies a conductive foil tape at certain points. Another machine rolls a clear sheet of plastic onto the solar cells. The plastic adheres to the cells, waterproofing and encapsulating them. A die press cuts out solar panels along the black insulator lines. The press uses computerized cameras for accurate cuts. A robot transfers each panel to the next station using suctioning heads. A computerized camera scrutinizes the panels for defects. After more testing, they deposit the panels on a piece of fabric. A laser cuts the fabric around the panels. Heated rollers bond the plastic panels to the fabric. Now, an employee burns through clear plastic film to reach the conductive foil. He solders wire to the foil at these points to connect the positive and negative leads. The wire is flexible and will bend with the fabric when it's folded. A seamstress now stitches strips of fabric over the wires, enclosing them in a protective pocket. Another member of the team solders a connector to a circuit board that's been attached to protruding wires. He squeezes silicone into a plastic cover and places it on the assembly. The silicone solidifies around the components to protect them from water damage. Finally, he rivets the cover to the fabric. This foldable solar charger is ready to be bundled up and placed in a backpack. It can power a laptop or a smartphone, keeping the user connected anywhere in the world. on how it's made. LED stage lights. Apple cider. Chemical tank trailers. And ornate stone floors. In the world of stage lighting, traditional incandescent or halogen bulb spotlights are making way for LEDs. LEDs are light-emitting diodes controlled by electronics. They use less energy, emit less heat, and can produce a wide array of colors without the use of filters. Incandescent or halogen stage lights produce just one color. The only way to create more is to shine the light beam through colored plastic called gel filters. However, this LED stage light uses 7 different colored LEDs, which can be blended into a variety of different hues. This computer-guided machine places all the components on the stage light circuit board, which contains 60 LEDs in 7 different base colors. Another machine measures and cuts pieces of insulated electrical wire. Then, the machine strips the insulation off the ends and crimps on terminals. The machine processes up to 26 feet of wire per second. Workers manually assemble 10 wires and 2 connectors into a control harness. The harness will connect the light's control board to the LED array. On the factory floor, they paint the stage light's 2-part cast aluminum housing. The paint process is electrostatic. This means the housing and the black powder paint are laced with opposing electrical charges. This spreads the paint evenly over the housing. Then the housing goes through an oven which bakes on the paint. Back in the assembly area, workers install the stage light's electronic components, starting with the LCD screen. It displays the current settings and modes, and the menus for changing them. After covering the screen with a protective plastic shield, they install the control panel. It has an opening for the screen. This plastic cover protects the LCD. It also directs outside air into the housing to the light's cooling fan, which they now secure in place with this bracket. The fan dissipates the heat the LEDs generate. This block of aluminum, called the heat sink, absorbs and quickly dissipates some of that heat. They mount the LED array on top of this 2-fold cooling system. Then they install the optic assembly. This plastic component focuses the individual LEDs. They construct the stage light's mixing tube, lining its interior with adhesive-backed aluminum mirrors. The mirrors mix the 7 LED colors into a single color. The assemblers now join the 2 halves of the mixing tube, adding a glass lens on the front. The lens focuses the light produced by the 60 LEDs into a single beam. Then they install the tube over the optic. Next, they mount the control card to the side of the mixing tube. The control card is the stage light's onboard computer. It processes the commands the lighting technician enters. Commands can be entered from the control panel or remotely from a computer. After installing the main power supply, they plug a DMX cable into the control card. DMX is the digital network through which the console or computer communicates to the stage light. They join this completed unit to the rest of the housing, which has the DMX and power connectors. This stage light is now finished and ready for a thorough quality control check. They plug it into a testing machine, which powers it up and verifies several functions. The machine also calibrates every color to ensure consistency in every stage light they manufacture. Then they run the stage light at full power for 3 hours non-stop to simulate strenuous operating conditions. Once the light passes these tests, it's ready for its stage debut. Apple cider is also known as sweet cider or soft cider. It's darker and cloudier than conventional apple juice because tiny bits of apple are not